What are common specific heat unit conversion errors? Imagine trying to cook a recipe but using the wrong measurements. In thermodynamics, mixing up units for specific heat can lead to big mistakes. When working with specific heat, it's easy to slip up if you're not careful with units. Specific heat tells us how much energy is needed to raise the temperature of a certain amount of substance by 1 degree Celsius or Kelvin. It's usually given in units like joules per gram degree Celsius, joules per kilogram Kelvin, or calories per gram degree Celsius. One common mistake is confusing mass-based specific heat with molar specific heat. Sometimes people treat it as per mole instead of per gram or kilogram. Remember, if the data is per gram, you need to convert to kilograms by multiplying by 1,000. If it's per mole, you need to know the molar mass of the substance to convert. Mixing these up can give you wrong energy calculations. Another mistake is mixing temperature scales without proper conversion. Celsius and Kelvin are similar in size, so you can treat temperature differences the same way. But if you accidentally use Fahrenheit differences or absolute temperatures instead of temperature changes, your calculations will be off. Always use temperature differences, not absolute temperatures, unless you're sure about the scale. Converting units between calories and joules is another common error. 1 calorie equals about 4.18 for joules. If you forget this or round incorrectly, your energy calculations will be inaccurate. Similarly, when converting grams to kilograms, remember that 1 kilogram equals 1,000 grams. Small mistakes here can add up, especially in large calculations. Specific heat can change with temperature and pressure, but many people use a constant value across wide ranges. This can cause errors, especially in fluid calculations like water or ethanol. Always check if the specific heat value you're using is valid for the temperature range you're working with. Sometimes, calculations involve volume instead of mass. In these cases, you need to use the density of the substance to convert volume to mass. Forgetting to include density or using an incorrect value can lead to errors. For example, water has a density of about 1 gram per cubic centimeter, but ethanol's density is different. Using the wrong density skews your results. Finally, outdated or generic data can cause mistakes. Always verify that the specific heat value matches the substance and conditions you're working with. Using old or approximate data might seem easier but can lead to inaccuracies. In practical terms, these errors can cause energy calculations to be off by several percent. For example, in designing heating systems, an 8% error in specific heat can lead to underestimating energy needs. This might make the system less efficient or cause it to fail. To avoid these mistakes, always double-check your units before starting calculations. Use exact conversion factors and focus on temperature differences, not absolute temperatures. When in doubt, verify the data for the specific substance and conditions. If you need to convert volume to mass, use accurate density values. Paying attention to these details keeps your calculations correct and your projects running smoothly.